So what needs to happen is I've got to have just the same kind of words. Because I've got cosines on the left and sines on the right, I can take the thing that's squared and I can make it turn into a cosine. If you have not seen that trick before, it's an important one to be able to come up with. Now we got 1 minus 3 cosine x equals 1 minus cosine squared x. If you can't see that trick, it would be difficult to solve. If I solve this one, it's a quadratic, so I want everything to equal 0. So cosine, because the unknown has something that's to the second power, to the first power, and then something that has no x's at all. The ones drop out. Now, you could solve this with the quadratic equation, or you could factor. I think some of you didn't like the word factor, and we used the word undistribute. I noticed that there is a cosine here and here, so I could rewrite that. So I unmultiplied is what I did. The reason I did that is that either one of those equaled 0, I could solve it. So now I have the solution that the cosine of x is 0, or the cosine of x minus 3 is 0.
Are you recording?
Yes. So now I can do x equals inverse cosine of 0. You get 90 degrees, or negative 90, which is 270. This one, there is no place in the unit circle that exceeds 1. Is that your way back there?
No, it's 1.
Yep.
There'll be no solution.
Yep. No solution there. If you do not like doing it that way, you can still try and do it graphically. If I was going to do it graphically, I can enter in one side of the equation, I can enter the other side of the equation. I missed a parenthesis. And a 3
on the top.
Sure did. If I do a zoom trick, now I happen to be in degree mode, Uh, Jared, this happens to be an RMS, like a root mean squared value. So if you're looking at the power of things, like on a speaker system, those will always be reported in root mean squareds or RMSs. That's what this happens to be.
That would make no sense at all.
It will eventually, I think, at some point in your life. Maybe not, though.
Yeah.
We started on that class.
I already figured out this. Okay, so we do volumes. And amplitudes.
That's what it is.
Not really.
Yeah.
I understand.
So the places I'm looking for are the intersections. Here and here. You can either trace to find them, or you could use the calculation function. You do the intersect. It's asking for the first curve, the second curve. It wants to know some place to start. Over. And you can say that it found the 90 for me that way also.